feeds, incoming video feeds, any of them that you don't need, just to make sure that we're kind to the bandwidth as much as possible. Okay, we were asked at the last time why we had a picture of just the GABA and not our traditional picture of a mascot for the local sports team. It was because the GABA actually has more than one kind of sporting event that occurs to it, but we were asked to select it. And so here you have Heater, who is the mascot for the Brisbane Heat, the local cricket team that does play at the GABA. He does remind me of Syndrome, personally. I don't know whether that the rest of you or not, but feel free trying to sleep through him as your cricket coach as you go to bed tonight. You have no doubt seen the note well by now, but we do like to remind you every time that there are a set of rules that we operate by. Those are reflected for you up here. They include the standards process, the working group process, the anti-harassment procedures, the code of conduct, the copyright information on how you deal with patents and participation here at the IETF, and finally our privacy policy. If you have questions about those, please find a member of the ISG and or your favorite lawyer. There is chat built into the MeetEcho tool. You're also welcome to use Zulip. The MeetEcho queue will be used for managing anybody who needs to make an intervention. We have already gotten a scribe, excuse me. Thank you very much, Martin, for signing up for that. I think many people get their start as scribes, then move on up to becoming working group chairs or area directors. So I just like to say, we really appreciate Martin taking the job. There has been a serious refactoring of the agenda based on what happened on our previous meeting. The scribe search were already done, but we're going to have the lessons from implementation, which has now been cut down to 15 minutes, bandwidth measurement in MOQ, 15 minutes, catalog and warp updates. That was something Will was going to do yesterday, but we're going to try and get in at lightning speed today, or I should say warp speed. Then the lightweight encryption for mock objects in 10 minutes. This is subscribe and fetch follow-up. This is the PR that was just landed shortly before the working group meeting started. So if you have a chance to go and look at the PR, that'd be great, but we're functionally not going to try and get through the whole thing today. And last 5 minutes for planning and administration. Since this has recently been bashed, I'm kind of hoping nobody has a bash again, but if anybody does, now's the time.
Ted, I have one question. Based on some of our conversations yesterday, maybe as part of the priorities presentation or one of the other presentations, is it possible to get a feel from the working group about what is necessary to go into the draft to have a productive interim on priorities whenever that happens?
Let's see if that falls out from the first one. If it does, that's great. Otherwise, we'll have to see about fitting it in. Again, it's a pretty tight agenda, and that could be a pretty big topic. In the meantime, let's go ahead and ask Suhas to take the floor.
Can everyone hear? Oh, so Ted, can you share?
Yeah.
So is my audio coming through?
Yep. Yes, we can hear you, Suhas.
Cool. So I have a delay here before it shows up. Okay, so I'll be talking about some experiments that we did while implementing the MOQ transport protocol, especially some learnings from our experiments when we tried to build a simulcast-based multi-quality video delivery or MOQ protocol. And the focus of our experiments was on the real-time use cases, so that we can someone can think of a conference application that's built over MOQ. And this deck basically talks about next slide, please. This deck talks about like multiple things in like at the very high level. I'll start with, how did we realize the simulcast implementation or MOQ? Basically, how did we use the MOQ data model, or how did we use the QUIC mechanisms there to kind of make the stream mapping work? And once we started implementing this and started trying out, we tried the implementation in different environments. Some examples included like running wired and some included running a stable network like an enterprise network, and many of the experiments that we ran involved asking people to run from their home Wi-Fi networks. And the more and more we asked people to run in these kind of different environments, we learned the network changes in everyone's home. The Wi-Fi network is not stable, and there's random losses that's thrown at you, and also the things like when you're walking around with a MOQ-based call, you see Wi-Fi because you're walking away from your Wi-Fi access point. There's a suspension that's happening, and you walk back. Things all together, things starts coming up with your network uplink and the downlink. And we also observed whenever the Wi-Fi driver on your laptop scans for the access point, it does induce latencies. The packets get held in your Wi-Fi driver, and it will be released all of a sudden in a burst. And these kind of things we were not aware until we started implementing and putting things out for testing. And that's when we realized, what kind of tools we can use. Like, can we use priorities here to help in some of those things? Can we use stream APIs to reset some things that go bad? So basically, we tried various tools, and under this not so good network conditions, what kind of issues we observed, and what tools worked and what tools did not work, and the changes that we have to make it work for the real-time use case with simulcast media delivery. Next slide. So at the high level, what is the ambition here? The ambition here is that in a typical conference, you have participants with or capable of sending multiple media types, audio and video. And with video, they're also able to sell multiple qualities. The reason why we do this is because we would have receivers with different capacities. Some are on mobile, some are on high-end devices, and we would like to reach the producer's video to multiplicity of receivers. And in order to do that one, we basically typically we have three qualities, like the 360p at the low def, and 720p at high def, and like 1080p at the medium, and 1080p at the high def. And the idea here is that, like, when you basically support this kind of multiple layers, we want a behavior to expect where if the network goes bad, we want the highest important, or like the audio and the low def video to go through when you're constrained on bandwidth or for any reason. And on the other hand, if the things get better, we want the high quality to go to the receivers. And we would want most of these things to be done without requiring explicit selection of media. So basically learn from what the QUIC's congestion control is saying and react to that one. At the same time, we want this decision to happen close to real time, so that it would be useful. Next slide, please. So this basically shows that the point that I made, where a source with multiple qualities and receivers going through relay, and each receiver is capable of receiving some set of the qualities or not, depending upon where they're coming from, their network hop, the issues on the congested links, or it might be the poor Wi-Fi network scenario where you're on a call and someone just starts watching Netflix and runs microwave oven. You'll see all kind of losses happening, and we want to be able to support this kind of different set of receivers, and being able to multicast those, and through relays reach these receivers based on where they're coming from. Next slide. So now, having said like what our experiment was, and to basically realize it or the QUIC, the idea here is that the source who has these multiple qualities and media types will send all the media on a single QUIC connection, and we map the media to QUIC streams and datagrams for audio, and we assign priorities to streams and datagrams as well. And the idea here is that we want to use the congestion control to help us guide when to scale up or scale down, and make some decisions based on that one, and ask QUIC to schedule the most important stream first. So whenever a QUIC stack is transmitting, setting the priorities based on the application preference here, where the audio is the highest priority, the most important one, and high def will be the least important one. Set those priorities on your objects, basically on the streams, and ask QUIC to schedule it properly, so that we can expect the behavior that we want under different network conditions. Next slide, please. And in order to kind of realize, handle kind of different network conditions that I explained, what we experimented first was have one stream per group mapping. Um, uh, Here, the idea here is that, like, if you're, say, sending 3 streams, high quality, low quality, and medium definition, and at any point in time you see, um, because of the network condition, your network, you're not able to push through a particular quality, you basically reset the stream at that group boundary and wait for the next group to start. The idea here is that, like, if the things are already bad on the network, we don't want to add things that does not really matter for the end-to-end user experience to have the end users to have what do you say, the continuous smooth user experience. So the first of the one of the tools that we tried was, if the stream is really falling behind, the SD is falling behind because we are unable to push this through, stuck behind retransmissions loop or something like that, you just reset the stream so that the 360p video and audio can go through. And also on some of these cases, because of how the congestion control works, on the receiver side, you do get mix of frames. Depending upon how quickly your congestion control reacted before you stopped sending the things that would make the things worse, the receiver still gets a mix of streams. So our naive implementation on the receiver side was, if you get like multiple qualities, pick the one that's best at that point in time and render that one. That way, and we have some way to not have a jarring effect on the receiver side, but the receiver makes a local decision saying that, at that point of time when I have to render, I pick the best quality that I have and I'm going to render it. And there's some cases where we also had this scenario where, if the receiver is seeing consistently bad qualities coming off the bad frames coming off the quality, that you basically go and unsubscribe because it's not helping. So it's kind of, it works, sender reacting to the network, at the same time receiver choosing the best thing it can do at that point in time, and also make a decision that if it really is not helping 1080p, then don't even bother to ask it about that one. That's one thing.
Just a quick thing. We have the queue, but I'm going to ask to wait because we have really tight timing. But I'm also going to tell you, Suhas, that we're 12 minutes in and you've still got 4 slides to go. So you might need to go faster.
Sounds good. So, and we set audio or datagram, and we set the priority at track level, and we apply that to that gets percolated to the different objects based on that one. You can go to the next slide. So what did we find? On sudden drops in the network capacity or jittery Wi-Fi delay, we saw that the congestion control will notice it after a delay around 2 oddities. When that happened, you basically end up making wrong decisions, and you end up queuing the frames like SD packets into the queue, into the network where they shouldn't have been gone. And this caused basically random losses, not just for the high definition packets, but also for the low definition streams. And this ended up causing more retransmissions and more delays across all the streams. Next slide, please. So one of the things that helped us fix is that having the retransmissions respect the original stream priorities really helped us a lot, because when the things got better and network is and you're able to send more data, the thing is, if the retransmissions did not follow the original stream priorities, then again you're getting mixed up data sent over the network. So one of the things that we implemented was having the retransmission also support the original priorities. Because of that, we were able to basically have, after the things come back, still have the priority order maintained. And also we worked on making in the Over QUIC, basically Christian worked on making the congestion control react faster, in the sense that we made some changes to the BBR state machine to handle suspensions better, and how to detect and react to the bandwidth changes slightly faster. That would help us in this in making this. And we would like to propose some of the incremental changes to the BBR in the upcoming IETF. Next slide, please. This is like, it's a teaser where we basically say the before improvements and after improvements, and if you look carefully, you'd see the reaction time at the RTT at the below graph would show the major change that happened before and after, where we are getting closer to within 100 to 200 milliseconds, we are able to react in the worst scenarios on the network, where earlier case it was like around 2 seconds, depending upon how the Wi-Fi network behaved. Next slide, please. So in general, we for the upcoming IETF, we would want to bring the experiments that we did by tuning the BBR to make it more real-time friendly, and also we would like to contribute how the sender setting the stream priorities actually helped in making some of the decisions as a relay to decide what to send and when to send next. Any questions?
Okay, so I've got Jana and Ian in queue. If you're going to queue for this, please do it quickly because we're going to also ask everybody to be very quick because of the tight timing.
Jana Iyengar, thanks Suhas for that presentation. The first thing is that just say PSA, everybody should be doing similar priorities for retransmissions as for transmissions, because otherwise it exactly ends up in the situation that you had. So that's a good catch, and you should absolutely do that. The question I had for you is, how often do you, I mean, I'd love to dig into the traces with you on this one, because it seems to me that there's a lot going on, clearly, but also how often do you have multiple qualities coming in at the same time? You have simulcast, which obviously you're going to have multiple qualities coming in, but I don't know how you separate out when you are under congestion. How do you know that you can't support just one of those qualities?
Right, because we implement the priority queue. So the priority queue, when the pick QUIC basically tells that it has the things to send, we send it in the priority order. So if the network is really congested, you end up backing up the low priority.
Oh, I see. Okay, that makes sense. Yeah. That makes sense. Thank you.
Thank you.
Ian Sweat, Google. Thanks for sharing, number one. So the priority scheme is the kind of existing-ish send order stuff that's in the current draft, right? It's basically a numerical priority scheme that's publisher-driven? Cool. Okay.
If I may, the priority scheme is pretty much that of HTTP.
I didn't catch that.
It's like HTTP.
Okay. Yes, that's what I thought. Okay, perfect. I mean, the thing in the current draft is fairly similar as well. Next is, who's canceling? Is it the subscriber or the publisher?
The subscriber, the publisher basically resets the stream if the queue is backing up for a particular quality. We have some like the depth of the queue based on that, and the subscriber can also react late. Subscriber reaction is a little later, but if subscriber is getting a lot of bad frames of particular quality, it can go unsubscribed too. But the stream is reset by the sender, the publisher, based on how network is reacting.
That's what I inferred. I just was curious. And then the last thing is, thank you for any input you have to BBR v3. I actually think it's a fairly good basis for a congestion control protocol that would work well in this environment. But I do suspect that there are some small changes that will be necessary. But thank you for any contribution you want to make. And yes, you're right. This is the wrong working group.
Thanks.
Yeah. Lucas.
Hi, Lucas. I had a clarification question that I thought got answered, but then I got confused because the response of this is like HTTP is confusing me, because there's multiple ways you can do HTTP priorities, whether they're sequential or incremental, effectively. I'm presuming this is trying to serve things sequentially, so the low order incomplete before the medium quality incomplete before the high quality. Is that correct? Or are we trying to round robin?
That's correct. Like the lower order has to finish first, and then the medium, and then the high def. Yeah, that's correct.
Okay. Cool. Thanks.
Okay, Victor. Sorry, we did close the queue before you got in it, so I'm going to ask you to take your question to either the chat or the list. There are several other questions in the chat, Suhas, if you want to give those an answer. The next person up is Ali.
Hello. Good afternoon. Can you hear me?
Yes, we can.
All right, perfect. All right, my name is Ali, and I'm here with my PhD student Zafer, who you met with in Denver, for those who were in Denver. So we have been doing a lot of testing and research on bandwidth measurements, and we are going to share some results today. Next slide, please. So this is a test bed that we established, and then the paper related to this test bed and some results will come out next month in ACM MMSys. I can share the early paper with those who would like to have a copy. So we have a live cam, and then this was also demoed in the ACM MyLive video last month in February in Denver as well. So we have FFmpeg live encoding and packaging, and then we use MOQ from Mike English, and then we have Origin.js as the origin server, HTTP server. Through MOQ relay, we have traffic shapers for independent traffics like TCP and UDP, and then we have open source .js client and MOQ player, and then we developed some monitoring tools to record things and so on. So today I'm going to just talk about the MOQ, the Orange pipeline. Next slide, please. So traffic shaping, just for those who wonder, we apply TC, which is the de facto, traffic shaper tool in Linux systems. So there are some details over here as well as in the paper. Next slide. So this is in a closed environment, 3 computers, source relay, and then the client. Test live source is coming in from FFM, FFM back through the webcam. Segment durations are 1 second, one GOP per second, and then 1 stream per GOP as well. Chunk duration is, this is CMAP packaging, so that's 1 frame per one chunk per frame, and that's 30 chunks per second. And then we have 4 video representations based on the HLS recommendations. And this is also, I would like to emphasize that this is an ABR system, so we are doing client-side adaptive streaming. This is not just a single stream or simulcast. So this is rate shifting on the client side. Next slide, please. So this is the user interface for those who haven't seen in number. We measure everything and then post them in real time. And I mean, in the demo we also had -js next to it, low latency dash, so you could appreciate the low latency nature of Over QUIC. Next slide, please. Okay, so we measure the bandwidth in 2 ways. We previously, it was last year in Seattle, we gave some, initial results. And then since then, we worked on a couple of things and we fixed some issues. So first, we have the passive bandwidth measurements. Passive means this is as we download data like video or audio, although audio is not included in this testing at the moment. We try to understand what the bandwidth is, what the available bandwidth is, and then how fast we can actually receive the data. So there are some equations, there's some technique over here, but this really has something to do with monitoring the incoming data when they were generated. Supposedly that's corresponding to when they were transmitted from the origin, from the publisher, and then based on the time that they were received, we try to figure out what the link can actually support. So this allows us to figure out, even if we are streaming at 3 megabits per second video right now, maybe the channel is going to support 13 or 30 megabits per second. So we can actually understand this. And then there's a paper on this as well that was published last year. Next slide, please. So this is the results. The blue curve over here is showing a staircase downshift and then upshift. So we are reducing the bandwidth over time, and then we are increasing the bandwidth over time. Here, dropping from 20 megabits all the way to 2 megabits per second, and then staying in every bandwidth value 6 or 10 seconds, if I remember correctly. And this is what we can measure from the ABR system. So this is not using any extra data, but just the incoming downloaded video data. As you can see, that's a pretty good job, except that there is one overshoot around 6 megabits per second. And then this is something we are working on. This is an overestimation problem, and then this happens when the client downshifts at the same time when there is a bitrate change in the network. So this is something we need to fix, but otherwise it looks quite promising. Next slide, please. This is again showing the same paradigm, but here now the green curve is showing measured over applied. So if we measure 5 and then the applied rate was actually 5, so I mean the network limit was 5, so this should be around 1, right? So we want a flat green curve, but as you can see, there are some overestimations as much as like twice when the client is downshifting because of the lack of bandwidth in the network. Otherwise, it's all pretty much around 1, a ratio of 1. Next slide, please. So the other approach that we also spoke about and then discussed a bit in Denver meeting was the active bandwidth measurements. It's called probing. So this is not using the actual video or audio data coming from the publisher, but this is using some dump data in the order of tens of kilobytes or so. And then we can do this on a probing channel. And then here we establish that channel and subscribe it from the client. This is something we already implemented, and we can share the code for those who are interested in. So we subscribe and we send a probe size, indicating how much data we want for our probe, and then we also indicate the probe priority. So this is a very interesting investigation point, because if we want the probe priority to be the lowest, we will underestimate the available bandwidth in the network. If it is the highest, we will overestimate. So finding the right priority level for the probe traffic is definitely something important. So here's an example. Subscribe probe channel, 40 kilobytes, and then I want the high priority. And this is not a continuous subscription. So this subscribe message is going to get you one probe. If you want to do it again in 1 second or in 2 seconds or in 10 seconds or whenever you want, you need to subscribe again. And then you get a subscribe OK message and then some dump data in that amount. And then you measure the bandwidth based on that. So we have probe frequency and then track priority and then payload size adjustable on this probe channel. Next slide. Here is some results. As opposed to overshooting the bandwidth in the passive measurements, here we have a bit of underestimation, undershooting problem. So the bandwidth is usually, just a bit below what's available in the network, and but otherwise it does still again a pretty good job, especially when the network conditions are improving. Probing works relatively well because you are already opening up some extra space for the probing traffic, and it works just fine. During time shift, it's not really working very well, but maybe that's something also we need to work on. Next slide, please. And this is again the same plot with measured versus over applied ratio. So again, we want 1 here. Instead of overshooting, we have undershoots, as you can see, as much as like 0.4. So it's like 60% less bandwidth measurement in some occasions. And still, this is promising, but it's not necessarily much better than the other issue. I guess it kind of depends on whether you want to undershoot or overshoot. Next slide, please. So our conclusions for now. Available bandwidth can be measured on the client side in a passive or active way. Obviously, it's not perfect. This is not really, this can't be really like a perfect measurement anyway, but I mean, it does a pretty good job. And for ABR purposes, and our client works just fine. Yes, there are some stalls or maybe skipped frames and things like that, but still, it gets the job done. Now, passive measurements have several advantages. There is no traffic overhead. We are using the incoming data, right? So there is no additional track like a prop track that you need to maintain or you need to create or you need to subscribe to. That's also a plus. And we don't need to find out a good value for, how big a prop message I should use or how frequently I should prop the network, or should I use high priority or low priority for my prop traffic? So those questions don't apply. But then active measurements have advantages too. So they can complement passive measurements. So our idea is to go with a hybrid approach. So do mostly passive measurements and then do only active measurements when necessary. And then active measurements also work reliably when there is not enough sufficient incoming data. So that's one of the issues with the passive measurements. If you are just receiving audio data, for example, from the publisher, passive measurements, fail largely to actually figure out how fast the network can send the data to you. But with the active measurements, that's where we can actually use them and pinpoint the exact value or a close good value for the available network. Now, this is an ongoing discussion, obviously, but I raised my concern about sender-side signals before. Again, I am not really against them. If there is a congestion window signal coming from the sender side, we will be more than happy to use it for the client side measurements as well as for ABR purposes. But we are not really planning to replace all this client side measurements with sender side signals, because that's really the cap, and that's not really a good estimate for the network bandwidth. That's what the sender thinks that it can send, but doesn't necessarily mean that's what the network can send. So that's it. Ted.
Thanks very much. I actually don't see anybody in queue, but I imagine people will want to dig into this and may contact you afterwards. So thanks very much for presenting.
All right, thank you.
The next person up is Will.
Yes, come on, camera. Okay. Firstly, let me start with an apology for the prior session. There was a calendar snafu on my part. I had put the meetings in very early when they were first scheduled into my calendar, and after they were moved, I thought the calendar entries would move, but they don't. So reminder to all to check. I appreciate the time slot today.
Can you, we need to get your slides up because they're on yesterday instead of today, which was our mistake. So if there's any vamping you can do to use the time efficiently. So I'm going
to cover it very, very quickly, 10 minutes, 2 subjects. The first is catalog, an update on that. And the second is warp, which is the beginning of the actual streaming format that's going to run on top of media over QUIC transport. There's a lot of discussion. Most of the debates you hear in these calls are about at the transport layer, but we do need to start thinking of how we're going to move media over this binary transport.
Hey, Will, since we're still trying to get your slides up, can we actually put Colin in your slot right now and then have you come back?
Yeah, that's fine. We've got so little time.
Sorry.
Do you need me to resend you the slides?
Oh, wait, maybe you want to just...
Actually, if I do a share screen.
Okay, never mind. Apologies for only having some of our ducks in a row.
Okay, scroll down, please. So the agenda, I want to present PRs and changes that happened since last IETF 118, then PRs that are currently open that you can comment on or review and approve so that we can merge them. I'll talk very quickly about adoption. Let's scroll to slide 3, please. So we did merge in, based on discussion of prior IETF, support for RFC 6902, which is JSON patching mechanism, standard mechanism for updating JSON documents, and catalog is in current form is a JSON document. There has been some feedback from this that it might be too heavyweight for some applications. I think, but I would like whoever is unhappy with JSON patch to open an issue and propose an alternative. Because the trouble is we're not an add-only modification. You can modify any component of this. And I feel that we might just reinvent JSON patch and call it something else, which wouldn't really be a step forward. So this PR is merged, but we're open to an improved update mechanism. Next slide. This PR got merged. I think it's a really good one, allowing relative track names. So previously in a catalog, you had to specify the namespace, but now we allow it to be inherited from the track that is itself describing the catalog. So there's an implicit namespace by the mere fact that you're reading a catalog track, and all tracks within the catalog can inherit that. And I think this will allow for decoupling the actual catalog contents from the namespace, which will be very useful when we get in a flexible distribution. And of course, you can specify the namespace within the catalog, so you haven't lost anything. We've gained a feature here. Next slide, please. This was another request. So we're on to open PRs now. So there was a request to move the fields to an IANA registry. The idea being that if we wanted to add new catalog fields in the future, we didn't want to have to go and do an RFC update. So I've created an IANA registry called MOQ Common Catalog Fields. It's going to be managed according to specification required, which is it's slightly below RFC required. I want to be open to there being other non-IETF groups who might want to define catalog fields here. And it's basically all the existing fields will be populated as initial entries in this registry. Next slide, please. PR 40 is to add a new field to indicate if Delta updates are to be expected. This was another requested optimization. A player wants to know, does it need to expect incremental updates? So we have a flag now on the left-hand side, support Delta updates true. It's Boolean. And it's particularly useful if we look at the right-hand side example. This is a catalog that is describing other catalogs, which is one of the capabilities of catalog. And you notice it describes two catalogs, and one of them supports Delta updates, one doesn't. So we have a schema where you can offer two versions of your catalog to clients, and maybe your simpler clients that can't handle Delta updates subscribe to one, and your more complex or fully featured clients can subscribe to the other. Next slide, please. And this is PR 42. I started implementing a little parsing class for the catalog, and I quickly ran into the notion that we have an assumption that any track properties that are floating around loosely in the root are to be inheritable by all tracks. And this I think is inflexible, because in the future, it's going to inhibit extensibility with that assumption, right? Because we might want to put other fields in the root that should not be interpreted as track fields. So if they are to be inherited, then I want to put them in an explicit object. So this object's called common track fields. It is what the name is what's on the can, and anything inside it is explicitly meant to be inherited by all tracks. This allows for compactness of catalogs, especially where we have lots of entries. Sharing a lot of common information. So if you like this idea, give it a thumbs up. If you don't, please suggest a change. This is just a picture. Scroll down. Next slide. Picture showing the same situation as above. On the right hand, this is just the evolution we've come from, and PR 42 is the situation on the right. We have an explicit object holding our common track fields. Next slide, please. And there was a call for adoption following the interim. That adoption passed. So thank you, everybody. There isn't actually the new draft at that link. I tried updating it. I'm getting a push error, which I will resolve with the chairs. I would actually like, before we move to a different ID, I would like to merge the open PR so we're not in this super weird state. So maybe we can debate that, but I will work it out with the chairs. And then once it's inboard and adopted, I think we can move forward with optimizations. I don't think there's time for questions. That's the last slide. Are we going to do warp as well, or are we out of time?
We only have a couple of minutes. Is there something?
Yeah, I can do warp in a few minutes.
All right.
Can you bring the slides up?
More speed.
Insert bad warp puns at this point. Okay, So warp draft update for Brisbane, agenda, let's scroll down. Let's go to the picture. So warp, as a reminder, warp is in the application layer. It's sitting on top of MOQ transport. Warp is an example of a streaming format. There can be many streaming formats. They may not even deliver video. They can do other things. But warp is going to be an example of a streaming format that can deliver both CMAF-based and lock packaged content. So scroll down. So it's comprised of reusable components. There's 4 drafts right now. There's catalog draft, which I just reviewed. There's CMAF over MOQ transport, which is available. There's lock over MOQ transport. So thanks to Mo and Suhas, they just released that. That's currently 1 document. I know there was discussion in the prior meeting. I missed it. I still hope that lock can be separated into a packaging component, just for how to package the media, and then a what is essentially another streaming format as well, so we don't refer to both. And then there's a separate draft for the warp specific logic, and there's 6 issues open on that. So that's the lay of the land. The collection of all of these is what we term warp. Next slide. There was a PR 20. This removed the packaging definition and moved it to an independent draft. That was basically executing that separation that I just spoke at on the diagram. I won't get into the details. Seems that's very useful for media that's used elsewhere in the industry. So we want to make sure that we have a compatible vector for getting it into MOQ and delivered efficiently. Next slide. PR 19, this was just, again, the mechanism. I changed warp to pull out any catalog specific stuff and refer completely to the catalog draft. Warp applies additional restrictions, for example, that the name of the catalog must be catalog so that we can find it. That's not a requirement for catalog, and there'll be other changes. Warp may also add additional custom fields for content protection, and those were discussed at the interim as well. Next slide. So timeline proposal, this is still in the work, and this is what I wanted to discuss most, but there's not time right now. The notion that we need to tell players, not so much for real-time communication, but certainly for interactive levels, live sporting events, and certainly for VOD files, we need to be able to communicate to the player what's the relationship between media time, warp clock time, and group number. So proposed a simple track for doing that. It's a JSON derivative of it right there. But if you go to the next slide, and I introduced this at the interim as well. If we want to extend JSON patch seems overkill, because in this case, we can't modify the past, right? So we're an append-only operation. So something as simple as CSV would in fact, I think, suit this very well, because a delta rapier can simply be a new line that we just add to the end. We append it to the end. So we might actually want to
just a real quick interruption. If there's any way you can get to the end quickly, because we're just running a little bit behind. There's a couple more things we need to get to.
Yeah, I can stop here. This is I think the last slide. So just a summary of core issues remaining. There's a lot of core issues remaining. So if you're interested in warp, please get involved. Thank you.
All right, thanks, Will. Next up is now we have Cullen. Run. Oh no, he beat the slides.
It's not hard to beat the slides.
Not by much.
Okay, so I'm going to be talking quickly about this secure objects, and this is next slide. This is a way of encrypting the objects. That's all it is. It's just straight up symmetric encryption. I want to be really clear. This isn't to replace anything that we use in CMAF for content protection or anything like that. This is purely for places where you're not using that and you want to do end-to-end encryption. Primarily some of the sort of cases that would probably be associated more with lock type things. So a real goal on this, particularly for the real-time stuff with audio in particular, is to really minimize the bandwidth overhead that we're expanding these objects out with each time that we do it. The technique here, there's no real crypto that we're doing here. We're just saying, use the standard crypto. IETF uses these HKTFs to expand out the keys and any AEAD scheme. I'd like to sort of highlight the point here that I regularly hear the IETF does not define APIs. They do. In fact, 5116 is nothing but an API. Anyway, moving on from that, we want to, so that's what we define it in terms of here. And this is set up to work with MLS, but there's no reason it couldn't work with some other key negotiation scheme if you were using it, but it certainly works with MLS. So that's basically the design goals. Minimize bandwidth. The relays don't know anything's different. It just looks like a mock object that they're forwarding like they'd forward any other object. It doesn't change any of the group IDs or anything like that. It doesn't change any information the relay look at. It's only the endpoints. Next slide. So the trick with AEAD crypto is we assume as a starting point here that we're going to have a key that we're encrypting the media, and that over time that key may get changed for various reasons. It might be that a given track always has the same key, but we want to have the option of being able to switch a key mid-track for some reason, maybe in a conference, as somebody leaving the group or coming back to the group. So there's also a key ID that goes along. And the key ID is just an incrementing integer that indicates the generation of the key and is an identifier for the key. Because we have that. So the prerequisites, we have that. We basically use the full track name, the keys, the ideas, the cipher suite, and some of these things to derive an actual encryption key that we're going to use. We also generate a nonce, and we generate this out of using the group ID and the object ID mixed with some salt. But the key point about this is that for these types of encryption algorithms, that nonce has to be not used multiple times with the same key. The key is unique to the track, and we're guaranteeing that the group ID and the object ID inside that track are unique to it. So that's sort of the main characteristics that we use of these existing IDs that allow us to basically reduce the amount of information we have to send substantially in actually sending the stuff across. So what we end up in the actual payload, we have the normal, whatever is in the mock envelope and things at the beginning. We're taking what's the data we're going to encrypt. We're adding before it a key ID, which would be a varant, so probably 1 byte in most cases. We're adding the new encrypted payload, which will include an authentication tag at the end. So the amount that this expands things is different. It's basically the size of the authentication tag for whichever crypto algorithm you're using, the padding of it, and the key ID. So it's a pretty minimal expansion of where to do. Last slide. One more slide, yeah. So if we're talking, just to give an idea of what that looks like, if we're talking about like low bitrate codecs, and we're seeing codecs that are going, sub 3 kilobits per second now and sound quite reasonable. And, we see some of the early versions of things coming out ahead on that. That's only 12 bytes per packet at even fairly large at 50 millisecond packets. At 20 millisecond packets, it's less than half of that. So even adding 1 byte plus some tags or something does substantially up the bandwidth of that. And that's really why the focus on low bandwidth. So this is a really short, simple draft. It's just at the sort of early stage of people starting to think about it and look at it. Just want to get people's attention on it a little bit, and that's where they are. Is there any questions I can answer about that?
So Jonathan, in the chat, you said suggestion JSON streaming format. Did you want to? Oh, for the previous one. Okay, sorry, it was delayed on my thing. I was wondering why.
For this one, I said GCM SST, but get the tag shorter. But that's a separate thing.
So, say that one more time.
For this one, I said I said in the chat GCM SST, which is the new proposal for shorter tags.
I mean that is AAD cipher. We could totally use that. We could also use the counter mode versions of it. But yeah, definitely would support both of those. We'd have to figure out which crypto suites we wanted later on. Thanks.
Okay, thanks, Colin. I think now we had Ian to talk for a few minutes about the subscribe fetch follow-up. Did I get that right?
Yeah.
I don't think there's any slides. Did you want to talk to anything in particular, or you're just gonna put heater back up?
Yeah, I didn't have slides. I'm happy to answer questions. I mean, there are a number of design details in there that I attempted to make a call on one way or the other. There are a number of things where you can spell things a number of different ways, as Suhas noted, like, whether something's open-ended, do you indicate that in, the number of groups you want to fetch, or do you indicate that in a type field or something like that? I'm not hung up on, as an individual, on kind of any of them, as long as we can come to a conclusion on all of them that like makes it really clear like what everyone is supposed to do, then I would be happy. But if there's any specific feedback about aspects of it that people want to discuss, in particular things that won't work or things that are problematic and aren't like editorial kind of commentary or like framing commentary, then this would be a great time to discuss it.
I just put it up. So if there's anything you want to have people look at.
No one's raised anything I think that is overly concerning so far, but I think Luke hasn't had enough time to look at it. It's also, I think, in the middle of the night, maybe there. I mean, yeah.
Luke just joined the queue.
Yeah, just joined the queue. I found an issue. Basically, I just don't know what you're supposed to do for the HLS- use case, the reliable live, how you're supposed to use fetch and subscribe. And I think just writing that out just as part of this proposal would help. Because I think it makes it really complicated.
Okay. Yeah, that's a good point.
Are there any other folks who've either read it or want to just put clarifying questions up there? We do have a few. We've been going at lightning speed, but we're actually doing okay right now. So if you have something to ask, you can. Colin.
I was going to say, I think that the classic HLS- streaming case is dealt with really easily on this, and it's perfectly reasonable for Luke to ask of like, hey, Claire, let's walk through this. But I'm glad to send an email to the list trying to walk through that. I think it totally meets those needs. So I'm very much in favor of like, let's move quick on this, and then as we, it's going to make it easier to deal with all our other PRs and stuff if we have this in. If we find mistakes, then start changing it.
Okay, Will.
Yeah, I might. Just a comment on fetch. I like the separation, but I read through the minutes from yesterday. It seems fetch is just centered around the live head. You can either get the group boundary before or the one that's going to come next, right? And the comment was that this meets the majority of starting media use cases. I think that is true for real-time communication, but that is not true for all other latency schemes. In other words, 2 to 3 seconds media. What you typically want to do is go back more than one group. That's a very common starting case. So and the proposed solution, which is that I do the subscribe for the live, and in parallel, I do a fetch once I know what the object is for something is behind. It's made two operations. You have to queue up data. It's just an ugly start to what will be, I think, a very common starting use case. So I would really like to extend the subscribe to include more than one back reference, which is pretty much where we had it before. But I think there's good reasons for being there, and I don't believe it places any undue burden on the relay. Back 3, it's just an engine.
So I completely agree that this is an important use case, and we need to make sure it works well. So the intent of going back one full group, one of the reasons that was added was because if you go back one full group, hopefully that is enough data that you can fill the pipe during that RTT that it takes to get the thing you are going to fetch. And so the subscribe fetch sequence, that takes an RTT, an extra RTT, but it shouldn't matter, because if you want more than one group back, it's hopefully going to take more than one RTT to deliver that amount of data. And so there should be, I would expect in most certain circumstances, no practical latency implication. And that's kind of why I suggested that as being a reasonable approach. I mean, we can do something else, but that was kind of my thinking.
Yeah,
Okay.
But the trouble is you're blocked, right? You're getting the later data first, but you need the earlier data before you can start. So you're having to hold it in, and that just seems an awkward construct for a start use case. But I'll defer to the queue.
Yeah, we have a few more folks in the queue, and now we are getting close to the end of our time. So, Jana.
Jana Iyengar, first, I don't agree that this is ugly. I think this is actually clean. And I'm happy to talk about why I think that is, but I won't spend time on it here. We spent time on it yesterday. And the key is that it doesn't seem clean if you don't think about congestion control or priorities. If you include those in your thinking, it might start to make more sense. It's a question of composability with core primitives, basic primitives, and this I think can work. If it doesn't, we can fix it later. I had a second point. The second point was I was going to respond to Luke's question about HLS dash. Did I hear correctly that Cullen, you were going to write out something for HLS dash and then Luke was going to comment on it? I just want to make sure that we have something here to help move us forward.
Sure. I think I don't know who needs to do it. I volunteered to do it. If somebody else wants to do it with me, great. But I think we need to do it. It definitely is a valid. If we can't accurately describe that, and if people don't agree it works, we have a problem.
I agree. I think we should get that nailed down ASAP so that we can get the PR to move ahead.
Okay, thanks, Suhas, and then Colin, quickly, please.
Sure. I think this PR is heading in the right direction, and I agree with Jana.
You're a little quiet, Suhas, if you can get louder.
Okay, sorry. I agree that this PR is heading in the right direction, and I agree with Jana that this makes things clear, and also a lot of open edge cases that we had with the way the subscribe is defined today. One API to do everything, it end up in implementation complexities, especially when you have multiple relays in the chain and to make a proper decision. And I did read, I've left some comments on 419. The issue, and I think multiple things has been raised there, and we need to kind of address them. But regardless, I would say as a group, we need to figure out how do we move forward on this and not stop the progress here. Thanks.
Okay, thanks, Colin.
Quick comment that I just want to remind people to remember that, like, if we did the thing where you could do a subscribe where going back more than one, you could go back, let's say, 5 minutes or something, or 5 seconds. Whatever a large group size is, we ran into that problem that if multiple subscribers, different clients all did that at sort of relatively the same time, we didn't know how to deconflict all those overlapping requests. So we had a bug on that issue, and that's, I don't think we have a solution to that problem, right? That's why we moved away from it.
Yeah, I'll also note that MOQ does not have a concept of time. And so though people discuss time as though it exists, it does not exist. It is not real.
Can the minutes please reflect that time does not exist?
Yes. Thank you.
For something that doesn't exist, we're close to out of it. Can I ask the area directors and the incoming chair to come up? As it's the last thing on our agenda was chairs - 5 minutes, and that's because we're making a change to the chairs. We're also making a change to the area director. Is that head? Get up here.
Yeah. So this is the last meeting of MOQ under Art. It is moving to WIT. So your new area director will be Zahed. It has been a pleasure working with you all, as much as I have provided not so much document support, but logistics and so forth. So good work so far. Keep it up. Keep him happy. Also, this working group chartered in September of 2022, and Ted promised he would help us for a year. He has helped us for a year and a half. Thank you very much, Ted, for all your help. As soon as he loses his dot, this will be your new other co-chair. All that happens tomorrow evening. So you're stuck with me and Ted for another 24 hours. And after that, we'll push all the magic buttons. So guys.
See what happens when you scribe.
Yep. It's true almost everywhere in the IETF. You take on a little bit of work and they give you more. This is what happens.
Yeah, this is exactly what happens. So thanks, Murray, for your service. Sure. And I hope we'll have a good time with Martin. He knows all about editing, so I don't need to do much job. So yeah,
get back to work, Martin.
And I would like to extend a very special thank you to Ted for all of the help that he's given to MOQ, starting with the working group forming BOF, and then through, this has been my first job behind the desk, and I could not have gotten where I've gotten without Ted. And so Ted also is getting a bar of mock chocolate to thank him for what he's done.
I really have to get carob, and then it'd be really mock chocolate. Well, thank you very much.
Well, and yes, and that means he's going to be our scribe at the next meeting. Paid in advance. Did you want to say anything?
No. Thanks, everybody, for being here today and for your contributions to MOQ. We will see you on the list. Take care.